Well, it's certainly a pleasure to be here today and to have a chance to share a little bit of some of our experience at Think Big around big data and what it can do and what it can mean. It's an exciting time in the enterprise. I think as those of you who are boxers know, the tides of change is really coming to IT, and it's a chance to innovate and create great value. So ultimately, when we started Think Big, it was because we saw there was this trend where some amazing new technology had matured and become available at pioneers like my old company Quantcast, and like these companies that you know of like Facebook and Yahoo, where people were wrestling with problems that required petabytes of data and new techniques which often actually been pioneered back at Google. So what we saw the opportunity to do is to start applying these technologies to create real value in a range of companies and industries that was broader than the first companies and use cases. And indeed, as we look, we see that now in 2013 that you've got big data is having an impact across a whole range of industries. You know, whether it's a software company, a hardware company, an online service, whether you're looking at marketing and advertising, supply chain and manufacturing, life sciences and healthcare, government, telecommunications. You've got a continuing trend of what people are doing and how they're using big data to really change the dynamic of their industries. So engaging customers with recommendation engines, detecting risk of people switching cell phone plans, responding to incoming events from devices. We'll talk about some examples during this talk of this, but across the board, the thing that we see happening is that you've got new sets of data with more complexity and needs to analyze the data and work with it in an unprecedented way that has not been possible before, is quickly becoming mandatory. So this change is really driven, if you look back, you had this trigger a few years ago of web-scale companies needing to work with massive amounts of data for things like web activity, advertising, geolocation. And the pioneers that often had a single application like web search for this technology found that it was incredibly good at providing an infrastructure for building a whole range of products and capabilities. And that's led to this trigger in the market, just a ton of innovation. The first wave of innovation came about really from open source, where you had community development, where a number of the early users of big data invested in technologies like Hadoop and Cassandra and HBase that were being built by the users for the users to solve their problems. And then the second wave of innovation kicked in, where you had venture investment starting to fund innovative product companies with an open source business model like a Cloudera or a DataStax. And then most recently, you've seen the third wave, where the large systems companies of the world, the EMCs and IBMs and so forth, have really kicked in and said that they're making this a core part of their product plans. So needless to say, what you've got is you've got this explosion of innovation, which is very exciting, but also more than a little confusing for people that are trying to figure out how to move from the promise of big data to real value in their organizations. So I think it's worth pointing out what are some of the impediments that people are facing. And I think you've probably seen lots of pieces talking about the promise of big data and how exciting it is, but it's just as important to think about what are the things that sometimes hold it back from achieving that value. I think one of the biggest ones is science projects, where you'll have in an organization, people will test something out, but they don't have a clear plan for how to really connect it in with the business and achieve something meaningful. Small efforts that don't have the resources to really connect through to an ultimate result. I mean, we've seen a lot of organizations where people are working in a playpen, and then a year later it's still in the playpen because they don't have the resources to really connect it and do something meaningful. definitely a skills gap. I would say that startups have generally had a better time with this. The access to the talent here in Silicon Valley is pretty unique, so you see more people with skills and aptitudes in this space than in a lot of other geographies, but it is a new space, and it's not just a question of being a really good developer or a really good analyst with SQL. There's some new tricks to learn, working with unstructured data, new methodologies for how to work with data, and distributed programming, and working in a cluster environment is also a little bit different. And I think the other impediments are often really applying older techniques. So especially in IT departments that have been used to business as usual and kind of cutting costs and not innovating, it's changing a mindset for how do you start to drive value from technology again. And I think Jeffrey Moore has put this well, talking about, hey, the tide has turned, that it's time for a new era of value creation from IT. And I think big data is a core part of that story about how you can really connect the business with value. So let's take a little bit more of a look. One example of a kind of application that we're seeing with big data is around device and software data. So you hear so much about consumer data, web, and online advertising, mobile. I'll talk about that later, but I think it's interesting to note that when you look at data that's being generated automatically by machines and by software programs, antivirus programs, servers in IT departments, software as a service capturing logs and information. These, and indeed, the Internet of Things, cars moving around, mobile phones. These devices that generate data, there's some really interesting capabilities of applying, again, big data techniques to working with those data sets. So from a technical standpoint, what you see is the explosion in unstructured data is ultimately being driven by machine-generated data. The structured data, or data that's being generated by people, is growing exponentially because the population of the world is growing exponentially, but at a much lower rate than we're hooking up machines with sensors and readings. So that the dominant term is really the growth of unstructured data from devices. So often you see organizations that are trying to cope with a scaling problem of how do they accept these massive volumes of data, and big data becomes an interesting technology to handle this problem. It also provides for a pretty unique ability to do analysis and an ad hoc analysis on data. So we often see the kind of three steps of how people implement big data. The first being putting in a basic infrastructure to hold the data and to be able to do some transformations and compute some basic analysis on it. A second step of starting to have exploratory capabilities, ad hoc analysis, to be able to poke at the data and understand it. And this can be incredibly powerful. And in a device database, this can mean having a more advanced support engineer being able to look at raw information about a problem that's not easy to resolve and quickly understand what's really going on. Could be useful for product engineers to do product planning, understand what are the kind of situations where customers run into a problem with this technology, and being able to look at real cases with ad hoc analysis tools. This is driven by the notion that with big data you can capture all the data and have deep history, instead of the classic paradigm prior to big data was how quickly can I get rid of the data, how little do I need, how much can I summarize it because I don't have the resources to deal with this stuff. In the big data space, it's about how do I create value from data? What new data sets can I integrate in to add value to what I already have? So that ability to capture history and blend data becomes very powerful. And as you go beyond ad hoc analysis, you get finally to what we think is the highest value use of big data, is starting to automate decisions. So building predictive models that increasingly drive automated response. So things like, for devices, identifying a device that might fail and proactively fixing it, or analyzing the root cause of a problem to be able to better mitigate it or prioritize defect resolution in software code base, identifying capacity limits that are approaching, controlling a system to mitigate the consequences of something happening. These are examples of predictive models on device data that the goal is not to have an army of analysts looking at spreadsheets saying, well, this thing is going to fail, so let's go fix it. It's to automate that and to have a better and better model that tells you these are the things that are going to fail, these are the things that we need to be addressing, and have people instead spending their time looking at how do we make it even better. So those are some of the cases of, if you look at that as from a technical standpoint, how device and software data analytics can benefit from big data. Maybe it's worth taking a quick look at what this might look like as an example of some of the technologies and flows where you might have data coming in from a variety of devices that get ingested in, blended with relational data, and then stored in either Hadoop or a NoSQL database such as HBase. And then ultimately that can be pushed out. So that environment can be used to hold the data, allows for ad hoc analysis, and it also allows for quick summarization with search indexing and low latency database access. And indeed can be fed into automated models to respond to events as they're coming in. So you get actually you have this closed loop of events come in and they're informed by information that's being summarized at the point that the event comes in. So we're applying a model that was predictive to understand what's going on. So you have this flow of different data sets coming together and using different technologies. I think that's also an important point is we're not going to talk a lot about all the different technologies that are being used in big data solutions, but it's not a one-size-fits-all approach. It's not a case of, well, you just implement Hadoop and everything is solved. I mean, Hadoop is great for batch analysis and for long-term storage and for doing some interesting predictive analytics modeling, but you need things like Solr for distributed search indexing, and you need technologies like HBase and Cassandra for low latency data lookup, and you still need relational databases for analytic summary data access for data analysts. So we see this being an elegant integration of tools that are best in class for what they do, coming together to build a great architecture to solve problems. So, what is the net effect? You put this stuff together, what is it really doing for the business? Well, as you think about this in device analytics, we see a number of interesting use cases. We see organizations that are driving increased sales, where it might be that are cross-selling or upselling, understanding the customer and what they're trying to do, better renewals, where you have an early warning, perhaps, of somebody using an online service that their usage is declining and they're at risk of churning. You can drive better service, with better customer satisfaction, reducing the cost of support by being proactive and having models, and by automating and simplifying, you can focus resources on the hard problems and make the simple things handled more easily. Of course, long-term benefits are harder to quantify around things like better product planning, but having data and not simply intuition in that area is really important. I mean, this is an extension of the now well understood idea that you should A/B test product features where you can to learn from data as to what's working and not. And indeed, those ideas of A/B testing and predictive models work quite well together, where you can build a model and test out a new approach to interacting with events, users, and prove that a new approach is more effective so that you can become the new champion, the new approach for how you interact. And then finally, we see interesting cases where organizations have data exhaust. They've got value in their data. It could be network data that they're monitoring. It could be data that they're capturing from interactions in a social environment. And they're saying, well, how do we generate new revenue? Is there an opportunity for us to actually have data become a part of our business model? Maybe it's blending some of the data we have with new data sets that we can sell it to third parties. Maybe it's enabling our customers with richer analytics, sandboxes to blend some of their data in with the data that we've got. But we're seeing that as another element that a lot of companies are thinking about of how do we take the valuable data that we're generating and make that more valuable to our customers. We also see that in terms of how companies are thinking about how they can use data to empower efficiencies across a supply chain and information value chain. So that's another important element too. So hopefully it's an example of some of the interesting ways that applying big data can really drive meaningful business outcomes. right? So again, the theme here is, and this is one example of an interesting area. There are many where big data can have a big impact. And we've worked with customers on a variety of these kinds of device nodes, with software companies, hardware companies, network providers, energy companies. So the applications are diverse of these technologies. You segue over to another industry. If you look at the retail industry, you've got, again, lots of pioneering application of big data. Recommendation engines is the first thing that jumps to mind when you think about how do you apply big data into a retail context, right? What is the best product to suggest that you might want to buy if you just bought something, or based on your past purchase history combined with your recent propensity, maybe you just did a search. There's other interesting ones too, like better identification of fraud and threats. Being able to do systematic market basket analysis. So doing things like looking at the combinations of items to say what, in a physical store, what items are likely to correlate and sell together that might be useful for promoting, offering promotions on one type of item to drive purchases of another. So it's about blending online and offline data. We see innovative new data sets coming online for retailers, whether it be video, whether it be using Wi-Fi to observe people walking through a physical store, locate products. Working with a company, Intelligence, that has an innovative service for mobile apps to let you find nearby physical products that you could purchase. So there's a range of innovative new data sets coming in, plus an increasing sense of, in physical retail, a blended environment where there's more online and more mobile activity. And of course, in the online world, there's a lot of activity already where there's rich data sets that are big data. So these things come together, again, in the retail industry, where there's significant opportunity to create new value by building customer intimacy. And ultimately, we think that when you start dealing with interactions with the consumer, big data has a tremendous potential to drive insights and engagement. It's a phrase that I think is becoming important, is systems of engagement, where a website, a mobile activity, these are ways that you're really engaging with customers and trying to build your interaction and understand them. And so how can big data help us with systems of engagement? Maybe this time we'll start from the business and then back into what the technical reasons are why these things happen, right? So classic example, again, in any system of engagement would be next best offer, being able to make good recommendations, good offers to people. In a world where increasingly people are accessing data on the move and with smaller screens, it's really important to have good ideas about what's appealing to them. If you have a big web display on a modern monitor, you've got lots of room to put many different ideas and options. But when you're down to a small cell phone or tablet, you need to be more focused on what is the user actually interested in doing, so you can present something relevant to them. Mass personalization, driving individual level offers is really important. We see this as a big shift. So many organizations we see are still thinking about how they engage with customers in terms of segments and sort of stereotypes of the kind of people and predefined rules, where some analysts will say, well, if the person has done this and this and this, let's put this thing in front of them. And we think that there's a big opportunity to shift to these big data-driven machine learned models where you have automated intelligence that says, this is the kind of thing that's really going to appeal to this person, not because they're in this stereotype category, but because we know these characteristics about them and it really is going to resonate. When we see this in applications for advertising, we see this in applications for online retail, we see this in generating offers for credit card holders, across a range, and we see this in retail banking, across a range of industries where you're engaging the individual, engaging them, really understanding their interests and taking the time to break apart their activities. It can drive great benefits. This can also be used beyond selling to people. It can servicing them better, understanding what's relevant to them, identifying customers that might be at risk of churning or reducing or removing their use of your service, finding fraud and risk, using big data techniques to stay one step ahead of bad guys who are trying to commit fraud, to identify giveaway patterns in that. Of course, that's an endless cat and mouse game where better technology is critical. Even assessing customer lifetime value. So, getting insights and engagement with the individual is a rich field where I think really these kind of big data-driven models have so much potential. And it's being driven in some sense by the increasing amount of data, right? That you've got mobile and web and geographic data, social data, CRM, and transactional data, and third-party feeds, right? So there's this range of data sets, and a lot of the magic, a lot of it is about being able to put these data sets into a common environment, and about being able to, much more quickly, in an agile way, try out ideas, test and learn. Most of the intuition, a lot of times what people try when they're doing this kind of data science is already accounted for. There's not an extra benefit. But when you find the new models that really have an impact, and you find things that really make a difference, it can have a big impact on the business. And when you think about this, another way of looking at it is Norvik's idea that better data beats smarter algorithms, more data beats smarter algorithms. That really a lot of what's possible now is to throw larger sets of data, more complete sets of data at a problem and drive better business results. And when you think about kind of the opportunity of the large-scale revenue in a big organization, or kind of profit margins, making a small difference on those metrics can make a big impact on the company. Stepping back, a little bit more technically, another important approach, another important area that we see often IT departments championing is this notion of a big data warehouse or a data lake, which is an idea of having an integration point for all the data in an organization, and kind of an active archive, and it becomes a platform for innovative tools for exploration and looking at data in a raw format. A place where you can have massive compute, where you have access to CPUs and storage at 10 to 100 times less price than traditional environments. And it again supports a range of use cases, from simply transforming and loading the data into classic analytic environments, up to use cases where you start seeing the ability to explore and analyze data with resources not possible before, and to ultimately being able to do back testing and sophisticated modeling to keep driving better and better optimization in the business use cases. From a business standpoint, this is often popular for technology groups because it can be a place where they start by cutting some costs, containing costs, but a lower cost environment with lots of capability. And the agile approach to analytics that this allows, of working with data in a raw form and kind of seeing the value in the data and then investing in more structure once the value has been proven, this can generate significant benefit by clearing backlog of IT projects and letting people have better access to data when they need it and as they need it. So we see across industries, organizations that adopt this technique are able to move a lot faster, maybe 4 times the throughput of how quickly they can test out ideas and do analysis in the organization. So those are some of the examples. Obviously, in each industry, these different examples play out in a different way. But we think that hopefully that gives a little bit of a taste for some of what people are doing with big data and some of the opportunity. We see this as definitely a journey, right? That many organizations have started from a traditional business intelligence and relational mindset, and that there's a series of steps to go from that starting point to being a data-driven organization. And we see that as putting together a roadmap, a plan, a notion of, we're really believers in the way you ought to approach this is with some business goal in mind. How am I going to impact the business? What is this new data going to let me do that's going to have a real radical benefit for my users, for my business? Not the mythology that so often is brought up of 3 data scientists in a cave work in isolation and magic comes out, right? It's a lot more. We think there's a lot of intuition around business problems, business opportunities where data can have a big impact, prioritizing those, and then focusing on a pilot where you really focus on putting the right resources to achieve a measurable benefit, and then use that as a foundation for further work. do more, test more, build up more of a portfolio of different projects to create more value, and start to invest more in data science and the platforms, with the ultimate goal being increasingly automated intelligence and an enterprise that is data-driven. So we think that to be successful with big data requires a few things. It requires real engagement of the business and the technology groups. You need executive sponsorship with that vision of what you can achieve in the business that's going to be a real meaningful benefit, so that there's a real vision with that of leadership. We think that there's enough complexity here that boutiques like Think Big Analytics that have smart people who work onshore closely with our customers make a big difference in speeding up the time to value and the cycles of delivering results. We think it's very much important to have a test and learn approach. The rules are still being written. The use cases, the details of how to apply this stuff and create value in your organization is going to be unique to you. And so the faster you can iterate, the faster you get something into production, it's actually driving a result from your investment. The sooner you learn, the sooner you can change and invest in the right way and improve. So that does mean integrating it into business processes, right? We really think using big data should not be about just generating some reports like you might have done with a relational database. It's about integrating into process and having a deeper alignment between the technology and the business side of an organization. So with that, it's worth pointing out how we like to help customers. We help with both the planning, what we call imagine, thinking through what's possible, what are the roadmaps, what are the technologies to use, what is it going to take to achieve a goal, illuminate, we have training and education on the various technologies and techniques, and then implementation, real hands-on engineering and data science to create the value, building these, assembling these analytic applications from open source and commercial product components. So with that, I'd like to thank you for listening to my talk today, and throw it open for any questions you might have. So the question is, who are our competitors right now? I'd say the biggest source of competition for us is organizations that try to go it alone and try to tackle these technologies and techniques on their own. They'd say, well, we'll learn it ourselves and we'll implement something on our own. And so often what we see is organizations get trapped on what I call the big data plateau, where they were able to put in Hadoop and start loading some data into it, but they didn't connect it with a business use case. They didn't have the ability to kind of connect it through to an end-to-end flow that's creating value. So that's probably number one. And number two is the market has picked up a lot, so you've got a lot of traditional systems integrators of one form or another, often offshore, saying, hey, we can implement this stuff for you. And they certainly can spell it, and they certainly will happily do work on a project, but we've seen it's not been a very successful model from what we've seen in our customers to have offshore providers doing this work. Other questions?
One is, can you give some sort of real-life examples on where customers have implemented big data and have seen some sort of value, what kind of value they see? And second is, reminder clock, say about 20 years ago, maybe Oracle, Microsoft, they were all switching their data centers with that. They were probably saying the similar messages about, hey, get our data technologies in your enterprise, and you can do all of this. So what's really different this time?
Okay, so some more concrete use cases, specific examples, and secondly, how is this different than what people were saying in the relational era? So certainly, to take examples, lucky here to have Kumar from NetApp as a customer, and they're a good example in the device analytics space. We started working with them back in 2010. They saw me talking about, I was giving a talk about work we've done with Quantcast, And they said, well, this is interesting, we'd like some help. And we helped them with, before Gartner was covering the space, kind of understanding who are the players and what's going on in big data. We helped them with a roadmap to plan out how they might apply some of these big data technologies to big data technologies to working with their storage devices installed around the globe for some of the largest customers to provide better service and support. We built a proof of concept for them that convinced them that not just the scalability and the cost advantage, but the ability to actually have ad hoc analysis to be able to look at data and troubleshoot and understand what was going on when there was an issue was significantly better with big data than with any traditional technology. Yet another re-architecture of relational to try to keep up with the scaling constants. And then they had hired us as the architecture leads on a large-scale mission-critical implementation to use the technology, which they had Accenture as the kind of program managers and global systems integrator. We were smaller back then too. That's we're continuing the journey with them. Well, I guess I can't talk yet about everything else. That's one example of a company that's made some significant investment in getting material advantages, tremendous benefits in terms of scalability, in terms of response time, in terms of being able to have better access to information. They've published some great case studies on that work, so that's a good example. We've also done work with large retailers, doing things like dramatically speeding up their ability to process information around complex transactions and be able to analyze it, and when they were having difficulties keeping up with daily calculation windows. We've done work with innovative companies in the consumer space around social video, helping them drive to better analysis and understanding of viral sharing and being able to better measure the effectiveness of ads that are running in their environment. We've done work for innovative companies in a number of different sectors. We've done, maybe thinking about in the consumer companies that are selling and doing more in the consumer space. We're advertising is a great example. We've done work with a number of companies in helping them build models to better predict interest for ads and to be able to pick the right ads that will get consumers to respond and to tune and adjust that, whether it be being hosted in the cloud, like a lot of startups, or large organizations, like a lot of marketing services organization that we helped blend their offline, personally identifiable information with online anonymous data to be able to better serve their customers, their large enterprise customers in the online world. So those are just a few of many examples of meaningful companies that are leveraging big data and creating real business value that we've been able to help. Now, in terms of your other question, what about what are some of the differences? Why is it different this time, right? And I think there's a couple of things. One is the relational database architecture that we've all been living with for the last 30 years was in fact designed around the kind of computers that were available 30 years ago, and the kind of networks and storage, right? That you just being able to touch the data once was hard. Being able to store it was almost inconceivable. It's hard to remember how much more capacity we have in all these dimensions than in 1980, right? Hard drives were extremely expensive, and a few megabyte hard drive was a big disk back when people started working with relational database. So the time it took to read an entire disk was way faster, right? Now it takes hours to do a scan of all the data on a multiple terabyte hard disk. So the systems have changed dramatically, and so there's a need to have cluster computing to be able to store and process data efficiently. The data volumes have kept up in a sort of a positive feedback loop of we can capture data we never would conceive of capturing before and use it in new ways. So at the one side, there's this demand, right? And I think we know this is different because we've seen a number of companies, many of them in the online space, many of them digital natives that have proven that they are able to process data and be data-driven, where they can come up with innovation and new ideas much more quickly with these technologies, that it is supporting an agile approach to working with data. And fundamentally, I think that's the difference, is that relational worldview has been one of, we need to put everything into neat boxes and pre-parse it and organize it so we can answer the questions we anticipated in advance. And big data is more agile. It's about putting data in a raw form and having it more complete and being able to go back and re-examine things. Why? Because we now have the resources to do those things that we never really could conceive of before. So I guess that's what I would argue, is that it represents a trade-off of having more compute resources to work with information so that we'd have less human resources working with information. Yeah.
So speaking of agile data analysis, it seems like many companies use distributed systems, but in a very centralized fashion. One data store that you dump everything into, as opposed to smaller data stores for structured. Challenges in one thing going one way or the other?
Sure. So the question is, it seems to the questioner that a lot of companies are centralizing these big data stores instead of having a more distributed model, and wondering if there's challenges with that. And we see a mix. I mean, we have customers that are very much interested in saying, look, we don't necessarily want to backhaul tens of terabytes of data to a common data center every day. We'd rather have tiering, where we have some amount of decisions, some amount of analysis and storage being done in each data center where we operate, and then we bubble some amount of information into a more central place for deeper modeling and centralized analysis. So there are cases where that model is being tested out, although it's not as common as in the case where we see a lot of decentralization and distribution is around systems of engagement. When you have a website or a mobile app where you're really trying to get low latency response to users, it's very common to want to have lots of data centers, so you can, the speed of light will work in your favor, that you can be closer to their machines, and you want to have a database that sits near them that holds relevant information about them. So that tends to drive the architecture of technologies like Cassandra, where you've got a database that's built. Companies that are interested in and thinking about how can they split some of the deeper analytics across multiple data centers, not have to move as much data around. So the question is, from companies we're working with, is there concerns about working with open source versus closed source technologies? And I think big data is an interesting wave of innovation. It's the first kind of fundamental technology that's being led by open source. In the past, you've had commercial technology lead a wave of innovation, and then it's been followed by open source once the form factor has stabilized, and there's now an opportunity to implement a similar technology in an open source project. With big data, though, the first commercially available and widely adopted big data technologies have been open source. So Hadoop, NoSQL databases, and in fact, you see Google is a pioneer in this space, kind of offering a commercial implementation later than the widespread adoption of the open source options. Right? So what we see is that there's still a testing ground. There's a number of companies that are trying open source and commercial models, and cloud-based models as well, which is it can be a kind of commercial model, it can be a kind of open source. But I think that over and over we see that there's a strong bias in favor of open source. And as I always like to say, if you think it's hard to make money in an open source business, try competing against one. Right? That it really has become the kind of the foundation point of a lot of the industry. Is that it's an open source led movement, and you've got companies that are applying various hybrid models of some open source technology and some commercial approach for how they can monetize and add value on top of open source. The question is, how do we work with companies in the healthcare space, and how does big data apply to healthcare? And we've worked with companies, a couple of different kinds of companies in healthcare and life sciences. we've done work on gene sequencing for a company that is gathering, has a fair amount of genetic data, rapidly growing amounts. And it's a very computationally intensive process, and definitely very rich benefits from the capacity of something like a Hadoop, in this case it was Hadoop, to do efficient models, to do sequencing and analysis. I think that one especially is interesting because what we see is that the dramatic drop in price of sequencing genomes is resulting in increased use in therapy as people are fighting cancer, they're getting sequenced. And I think in the next few years, as the price continues to drop, that's going to become a more and more prevalent thing, that you're going to see clinics where they routinely have a big data problem. Anyone that's treating cancer, that they're going to be having lots and lots of gene sequencing, and they need to be able to do comparisons and analysis. That's just one of many areas, though, in healthcare. Lots of interesting work around how can you have better predictive outcomes to understand what's likely to work or not for somebody. Can you have a better model that's not just what's the one size fits all, but individualized medicine, better predictive models of what's going to work for you, and how quickly can you say this therapy isn't working, we need to do something else, right? So I think there's a lot of promise and opportunity there to do good, as well as being a technology that can enable upstream drug discovery, and that was actually another customer of ours, was applying big data to better predict regulatory issues where there might be a problem in a given therapy, so that to try to use big data to better identify those problems and minimize waste in the investment process for large pharmaceuticals and medical device companies. Just a couple of examples. Yeah.
I think it says quantity of the data. What tools do you use to avoid the garbage in, garbage out? The second part of the question is, maybe some sampling techniques to expedite the process.
So good questions. How do you assess the quality of data and avoid garbage in and garbage out? And do you use sampling techniques to expedite your analysis? Well, I definitely, to take the second one first, it's very much the case that you want to build up analysis incrementally in a big data system. So you typically want to start any kind of work or analysis on the laptop, and then a small sample in a shared environment in a Hadoop cluster, and kind of build up and encounter and make sure your analysis is sound and you understand what's going on in smaller scale, and then incrementally build up. Even if you've got a 1,000-node cluster and petabytes of data, you don't want to just turn a huge computation loose on that data and then discover, oh, that wasn't a very good idea. I didn't form that question quite right. Let me start over, right? You want to kind of have worked your way in and understood the problem and incrementally build up. And this is always an education process, that and sort of some of the basics of how to tune and run things efficiently in a big data environment. But to the first question, how do you deal with data quality? I think it really is, it's incrementally. So the notion is, instead of having the old idea that you want to have everything be cleansed and perfect, and you kind of put a lot of work up front, speculating on this is going to be a valuable data set, this is going to be a valuable thing to work with. In the agile analytics mold that big data enables, you start off with data in raw form, and you put some approximate structure, and you start to understand. And as you've proven values, you say, wow, this is really promising. We're seeing a lot of signal here. That's when you start to invest in structure and governance and all the same requirements apply, right? If you want to share amongst a group, you need to have documentation, you need to have change control. But the difference is you want to invest in those things only after you've shown them value and only after you've got some standards, instead of doing it up front. But fundamentally, those laws of physics apply, and we do see a lot of organizations that have underinvested. There's been a lot of the early adopters of this technology have been a little bit more of a Wild West atmosphere and have underinvested in governance, and it does cause problems downstream. Yes.
The pros and cons architecturally going graph versus
So the pros and cons of going with graph versus
electric graph.
So, there's different technologies for analyzing graphs. I mean, there's some that are, there's technologies like Titan and like Faunus that are a couple of open source graph technologies that work on top of Hadoop, the Hadoop stack. Then there's often specialized graph databases like an Objectivity. So I would say that it's still pretty early on in terms of using different graph techniques in the big data space. There's a lot of nascent projects, but I would say that there's still it still hasn't been as proven out and as widely adopted. Right? So I'd say that we think that there's clearly value in being able to apply graph techniques on top of a Hadoop stack or on top of a Cassandra as standard technologies rather than using something that's more specialized. And instead, what's been used a lot more are tools like Neo4j that are more hardened and certainly more proven out, but typically have some scale limits that are more difficult to work around, right? So for medium-sized graphs, there's a lot of mature technology, and it's more experimental for truly large-scale graphs. Any other questions?
Does your company provide the training, or?
So does our company provide training? Yes, we offer training on both technical elements of big data, data science, Hadoop, HBase, as well as upcoming training we're working on for Storm, as a streaming real-time big data technology. And we also have business seminars to help business leaders understand what can be done with big data. All right, well, thank you very much.